What if one tiny peptide in your gut could control your blood sugar, your appetite, and even your body weight? Not just control it, but revolutionize how we understand metabolism. This is the story of GLP-1, a naturally occurring peptide that went from being an obscure scientific curiosity to one of the most talked about breakthroughs in modern health science. But here's the surprising part. GLP-1 itself wasn't enough. It was unstable, short-lived, and almost useless in its natural form. So how did scientists turn it into something powerful? And why did this discovery change everything? What is GLP-1? GLP-1 stands for glucagon-like peptide 1. It's a hormone your body naturally releases from the gut, specifically after you eat. Think of it as a metabolic messenger. Its job is simple, but incredibly important. It signals the pancreas to release insulin, it slows down how fast food leaves your stomach, it reduces appetite, and it helps regulate blood sugar levels. In short, GLP-1 helps your body say, "Hey, we've eaten. Let's handle this properly." But there was a major limitation. GLP-1 doesn't last long in the body. Very long. The problem? Short half-life. Natural GLP-1 has a half-life of just a few minutes. That means your body breaks it down almost immediately after it's released. An enzyme called DPP-4 destroys it rapidly. So even though GLP-1 has powerful effects, it disappears before it can do much. For years, this made it almost impossible to use therapeutically. Scientists knew GLP-1 was important, but they couldn't make it last until something unexpected happened. The breakthrough. GLP monster. The turning point didn't come from a lab. It came from a desert. Researchers discovered a peptide in the saliva of a lizard called the Gila monster. This peptide was called exendin 4, and it behaved very similarly to GLP-1, but with one crucial difference. It didn't break down quickly. It lasted much longer in the body. This was the missing piece. Scientists realized they could create GLP-1-like peptides that resist breakdown and stay active longer. That changed everything. From discovery to application, once researchers understood how to stabilize GLP-1 activity, they began developing analogs, modified versions of the natural peptide. These analogs were designed to GLP-1 receptor agonists. Instead of disappearing in minutes, these peptides could now sustain insulin signaling, reduce appetite over longer periods, improve metabolic control. This wasn't just a small improvement. It was a complete shift in how peptide-based therapies could work. Why this mattered? Before GLP-1-based approaches, managing blood sugar and appetite was far more limited. GLP-1 changed the game in multiple ways. 1. Dual action. It didn't just affect one pathway. It worked across multiple systems. Pancreas, brain, gut. 2. Appetite control. It introduced a powerful biological mechanism for reducing hunger, not through willpower, but through signaling. 3. Metabolic efficiency. It helped the body respond to food more intelligently. 4. New therapeutic category. It opened the door to peptide-based metabolic regulation at scale. In simple terms, GLP-1 turned peptides into a major force in modern medicine. Popular GLP-1 peptides. Let's look at some of the most well-known GLP-1 peptides that emerged from this discovery. 1. Exenatide. This was the first major breakthrough. Derived from exendin 4, it proved that GLP-1-like peptides could work effectively in humans. 2. Liraglutide. A major improvement. Scientists added a fatty acid chain to the molecule, allowing it to bind to albumin in the blood. This extended its duration significantly. Now it could work over an entire day. 3. Semaglutide. This is where things escalated. Semaglutide pushed the limits of peptide engineering. Much longer half-life, stronger receptor activation, weekly dosing potential. It showed just how far peptide design had come. 4. Dulaglutide. This peptide took a different approach. It fused the GLP-1 structure with a larger protein component, making it even more stable and long-lasting. 5. Next-generation hybrids. Now scientists are combining GLP-1 with other pathways. GLP-1 plus GIP-GLP-1 plus glucagon, these multi-target peptides aim to enhance metabolic outcomes even further. The bigger impact GLP-1 didn't just create a few successful peptides. It reshaped an entire field. It proved that peptides can be engineered for stability, hormonal pathways can be targeted precisely. The gut is deeply connected to metabolism and appetite, and perhaps most importantly, it showed that small molecules can create massive biological effects. From a fragile gut hormone to a global scientific breakthrough, GLP-1 is one of the most powerful examples of how discovery, biology, and engineering come together. And we're just getting started. Because the next generation of peptides, they're already being built. If you want to understand peptides, metabolism, and cutting-edge science in simple terms, subscribe now. Because this channel breaks it all down.